We're now well into the build season on the FRC rebuilt season. Let's take a look at some what teams have come up with. The thing to recognize, I think, about intakes is at this point in the build season, what's probably more important is that you take an idea and you stick with it and just iterate to work beyond it. I'm Brogan Pratt, and I've been teaching robotics and design for over a decade now. And today we're going to take a look at how teams have been iteratively improving their shooters, intakes, and indexers for the rebuilt season. We'll also take a look at some full match footage as well. So first up here, we've got team Makers Assemble 5951, and they've been improving their shooter here. They've got a plank of wood just to hold things off of their shooter. It looks like the moment so that fuel doesn't get lodged in. It looks like you've got a belt down on the bottom that is able to transfer it. And my assumption here is that they've got a belt on the top and on the bottom, as well as several other belts here to be able to drive these up and into their indexer, I think, or into the actual outtake. One of the really critical things here that you want on your indexer or your movement portion is the goal of your intake is obviously to pick fuel up off of the ground. The goal of your indexer or your transfer system is to always reliably take it from an unknown location or a more kind of sporadic location and always bring it to the same location every time. And for the most part, this prototype looks like it's doing a pretty consistent job of being able to consistently bring that game piece back every time. We've got another one here from Tech Knights 334. They've got another shooter and hopper design with a rather wide shoot as well. They've got, looks like it's can fit almost 2 or 3 drums in there, and they can clear out what looks like probably 20 to 30 pieces of fuel in a very rapid, short period of time. Now, of course, they're running their intake here, or not intake, this is their main transfer system off of a drill. Totally fine in this case, but it looks like they've actually do have some DC motor setup with looks like a generous hunk of metal there for the side of their flywheel to be able to get up and going. And clearly it's got more than enough throughput to be able to manage what it is they need to do. One of the things that we kind of talked about last week was the importance of teams thinking about whether you're having a fixed shooter or a hooded shooter, and having something wider as a fixed shooter means that it's easier for you to empty your hopper a lot faster. However, on the flip side, you could take something like what Team Rembrandts are doing here, where if having a turret allows you to move while you're also shooting. Now, at this point, it's not quite clear which strategy is going to be more advantageous or not. One thing that is challenging about the move while shooting is if you are changing the distance from your robot away from that turret, changing flywheel RPMs to be able to speed up or speed down that flywheel is rather challenging on a short period of time just because of how much mass is on these flywheels. So instead, if you are going to take the turret route, you should definitely have some sort of hood that is able to be adjustable, because without an adjustable hood, it's going to be really challenging for you to be able to modulate that RPMs on your flywheel to be able to have different distance-based shots. I still think it's a totally valid way of doing some of these designs and quite successful. We've got Team Link FRC as well here, doing another kind of double wide fixed shooter here. And they're just taking a huge cardboard box filled with fuel to be able to show up just how much they're able to get some of that high throughput through and then still keep some of those artifacts in there as well. So it's yet to be decided at this moment whether a super high throughput or a hooded shooter is going to be more advisable. One thing that might be more challenging than teams could be expecting this season is that some of the fuel in the center may be a lot more interspersed than they expect. And let's talk a little bit about that when it comes to the intake. Actually, before we do that, we'll talk about FRC 3161 here, taking some shots on their close shooter here. One thing about doing tests like this, obviously you can't tell from this shot, having a high throughput here, it does look like their flywheel is starting to lose some of its inertia as it gets down to the bottom, because we see at the start here that they're able to launch balls over here, and then as time goes by, some of their balls are starting to launch almost a meter further back. So they might need a little bit more weight on that, or have that hooded shooter compensate as that comes down if they don't have enough on that. As far as the intake goes, I want you to see a video here from some autonomous testing from Team 360, the Revolution, and just take a look at, as this robot comes along to try to pick up artifacts, just how much they are pushing more fuel out of the way before it comes in. So when it comes to that intake, and then it really does have just this very sprawled section of fuel all over. That the concept of taking and owning it, I think, is really important, and you're not going to have this large section of fuel for a very long time to be able to come up and feed and have some of these extremely full hoppers. So being able to fill your hopper up relatively quickly, I think, is probably going to be more of a challenge in terms of a driving skill issue being able to come around. When we talk about indexers, I want to show off something that hammerheads have thought of here just as a way of being able to keep their hopper up and moving so that they can shuffle more of their fuel inside. So I think this is a pretty interesting way of being able to feed more things into that turret. Back on the idea of intakes, I think it's really important to be talking about just how much fuel can you control and take it and own it. So we've got team 571 from Paragon Robotics here. And what's really important when you're doing a lot of these intake testing is to try to simulate as much of real world events as you can. Try to get as if you're feeding those fuel in there at such a short period of time. But having a series of long PVC rollers seems to be quite successful. I'm not sure if they have grip tape on the top of these or whether it is just simply a PVC pipe where it's silicone molded. We've got a team over here doing intake. This is Avalanche Robotics from 2724, and they've done a little bit of custom molded for their roller bars. I love seeing students be able to design some of their own parts, things like their own silicone parts and extra manufacturing in ways that are beyond things like a laser cutter, 3D printer, or CNC. It's awesome to see some of those extra skills being built over time and, for the most part, pretty successful. The thing to recognize, I think, about intakes is at this point in the build season, what's probably more important is that you take an idea and you stick with it and just iterate to work beyond it. Because at this point, we've seen that boot kickers work pretty well. Flapper wheels work pretty well. Straight PVC bars work pretty well. PVC bars with grip tape on them work pretty well. Aluminum bars work pretty well. Compliant wheel intakes work pretty well. For the most part, there's a lot of things that work, and the teams that get these things successful are the teams that iterate upon the design to make sure they have different compression rates and things like that to be able to have those things up and successful. I want to show off Lake Robotics here, 5053, just because I think they are really pushing out the idea of, taking it and owning it. Whether this thing is fast enough or not, I'd be curious to see this if they were moving this robot a little bit faster. But it does look like they've got a quite good amount of speed on that intake bar here, because as they touch a fuel, the fuel literally looks like it just disappears inside of the robot. It's coming inside so quick. I love seeing it. I think that's a great strategy for taking and owning it, and some teams could definitely take some points off of that. On the autonomous front here, I want to show off from a user Kai C talking about fuel object detection and being able to set up some different. Now, this user did set these things up with a Raspberry Pi as opposed to with a Rio and some different camera vision systems. But the importance of thinking about how to collect these fuels during that autonomous section. How do you know where clumps of fuel are to be able to go in when you are autonomous? And how do you know whether you are going to be picking up the accurate fuel or not? And it's great to see teams already starting to think about this and already starting to use some YOLO models, things like that, so that they can actually start to figure out where are clusters of fuel and then where are individual fuels. Because you probably don't want to pick up the one that's simply closest to you. You probably want to go for larger clusters of fuel, or being able to even string together a path of several fuel together in a row on that autonomous to be able to get beyond that 8 sort of preload that you have setting inside there. Last thing that I want to show off here is, of course, Fun Robotics Network. Everybody knows these guys. They are doing some fantastic stuff, and they have just released their mid-build competition this week. I'm not going to show too much from this, but I think what's really important here, looking at their mid-build, is just looking at how sparse some of this fuel can be. Now, I don't think they're using quite enough fuel here, but similar to what we saw with this auto from FRC 360, I want you to watch this blue robot in the backhand corner as they come around to pick up some of this fuel, just how much these things really spread across the field. So if you are not taking it and owning it, what can end up happening is you end up just spreading around a whole bunch of fuel as opposed to bringing up and bringing it into your robot. So if you are going to take a strategy of something like a hooded shooter, where you're capable, or a turreted shooter where you're capable of rotating and be able to fire while you're moving, I think that's a totally your intake's not near as important. Whereas if you're going to take a fixed shooter and your strategy is to make sure your hopper is as full as possible to be unloaded as quickly as possible, really having that concept of taking and owning it is going to be really critical in this point in time. I recommend everybody go take a look at these mid-build competitions so you can take a look at how things and how different strategies are already starting to flush up, because we're starting to get pretty close to when teams are actually going to start doing some of their competitions, and you want to make sure that you are ready and prepared. It's also a great reminder just the importance of driver practice and making sure that your driver is rather skilled with that driver practice so they can be moving around and knowing where it is they need to be able to get themselves that best performance. If you're looking for more CAD resources, code snippets, files, things like that, you can consider joining my community down below. If you have some submissions you think that the community would benefit from looking at some different designs, I also have a submission form down there for FRC Saturdays. And as always, best of luck to your team this season.